Welcome to BTEC Revision. In today's lesson, we're looking at acceleration. By the end, we should be able to calculate the acceleration of objects. Acceleration is the rate of change of velocity. So it's a measure of how much velocity is changing over a given time. The units for velocity are measured in meters per second, and time is measured in seconds. So therefore, acceleration is going to be measured in meters per second squared. The short form of acceleration is A equals delta V divided by delta t, where A stands for acceleration, V for velocity, t for time. And this triangle represents the change in. So looking at this change in V, this is going to represent the final velocity. We can write that as V, take away the initial velocity, and we'll write that as U. We'll learn more about this next lesson in Suva equations. For example, let's take a car at rest. That's going to be its starting velocity, or U. And let's say that's 0 because it's at rest. And it starts moving and reaches a final velocity of 10 meters per second. That's going to be our V value. That's 10 meters per second. So our change in velocity, delta V, equals 10 take away 0, which is 10 meters per second. Now, let's look at this example. Calculate the acceleration of an initially stationary object that reaches a final velocity of 50 meters per second in a time of 5 seconds. So we'll take this equation, acceleration equals delta V by delta t, and we'll plug in our values. So delta V is 50, take away 0 because it's initially stationary, and divided by the delta time. So that's going to be 5 seconds take away 0, and we'll get a value of 10 meters per second squared. Now pause the video here and attempt this exam question. We are going to calculate the initial velocity of an object if its final velocity is 100 kilometers per hour and it has traveled for 1 minute with an acceleration of 0.2 meters per second squared. So the first step we can do is write down the values that we need. So we need to work out the u, which is the initial velocity. We have the final velocity, which is v, and that's 100 kilometers per hour. And we can see that this is in the wrong unit, so we need to convert that. And the time, t equals 1 minute, which is also in the wrong unit. And we have a equals 0.2 meters per second squared, which is the correct unit. So let's start by working out the velocity in meters per second. So we have k, which stands for 1,000. So we can see that is 100,000 meters, and then divided by 1 hour, which is 60 minutes, which is 60 times 60 seconds. So that's 3,600 seconds. And if you work that out, we should get a value of 27.7 recurring meters per second. Now, time, that's easy. 1 minute is 60 seconds. Okay, so if we look, we can work out which equation this is going to be. We have A, V, U, T. So this needs to be the equation that we're using, which is A equals V take away U divided by T. Now, we need to make U the subject, so we can rearrange this. So multiply both sides by T, which would give us T times A is equal to V take away U. Now we want to make U the subject, so we will add U to both sides, and we'll take away TA on both sides. So that will give us U is equal to V take away T times A. And now we can just plug in our values. So that would be 27.7 recurring. take away t, which is 60, times 0.2. So, plugging that in, we get a value of 15.8 to 3 significant figures, and that would be meters per second. And that's the end of the lesson. If you'd like to boost your grades, visit us at btechrevision.com, where there's lots of quiz questions and resources available. See you next lesson.